So here is a B version of estimating square roots, and this will be more applicable to square roots of large numbers or long decimal numbers. The steps are gonna look like somewhat like my previous estimation video and also the square root computation. So let's look at some 3, 4, I don't know, 6-digit numbers. How about that? Okay, let's get started with something easy. How about the square root of 8025? Okay, now that's a big number. So remember, in square rooting, you need to come up with two factors, two numbers that multiply, two identical numbers that are the same numbers, and they multiply together to be 8025. Alright, this you do. 8025 is the same as 8025.0. Alright, so I'm going to put the otherwise invisible 0 there. You chop it up into 2-digit chunks starting at the decimal dot. Yeah, come on in a little closer. You chop up this number into chunks of 2 digits. The one closest to the decimal dot, that's going to be nothing, just ignore it. Seriously, that's going to be 0, and you only deal with 80. Okay, what times what is 80? Let me see. Well, 7 by 7 is 49, 8 by 8 is 64, 9 by 9 is 81. I guess 9 is close enough. The answer is 90.0. The answer is 90. That's the estimation. Okay, that's kind of close to somewhat equal to, approximate it to be 90. Let's check it on a calculator. Square root 8025 equals there, so you can see the numbers 89.5. So that you can see it works this way. It's pretty close. Now let's see another one. How about a 6-digit number with a long square root? How about 62? Oh, sorry, I poked your eye. 6253. I don't know, 51. How about the 6-digit number equals? So there is your invisible 0 there. Same thing. Chunk the number up into 2-digit parts. That's gonna be a digit 0. That's gonna be a digit 0. And 62. Let me see. 7 by 7 is 49. 8 by 8 is 64. I guess 8 is close enough. The answer is 800.0. 800 is my there. Estimated to be 800. Let's see. Square root sign. There, I can tilt it a little bit. 625351 equals 790. Ta-da! We're pretty good. See, 800 is pretty close to 790. This thing works. Now, what do you do when, say, 8 by 8 is 64? Let me just change that number a little bit into a slightly different one. What happens if we have, say, 57? Because 7 by 7 is 49. So something between 49 and 64. I want a number kind of halfway between 49 and 64 there. So 57 is about halfway there, and the rest of the numbers are just staying there. So 575,351. You need the square root of that. Same stuff. Chunk it up into 2-digit blocks. That one is just a 0 now. That one is nothing now. And this one is 7 by 7 is 49, but between 49 and 64, 57 is kind of halfway there. So what you can do with the half, with that 0.5, because it's a 7.5, where you put that half is here. That's a 5 now. 750.0. Let's see how this one works on a calculator. Square root of 575351, 758. See this one works. And let me just put one more here. Okay, just a 4-digit number. That's the same idea. How about 1234? 1234. Square root of 1234. Again, you have this invisible 0 there, and starting at the decimal dot, cut up the numbers into 2-digit chunks. That's a 0 there. Now 12 is halfway between 3 by 3 is 9, and 4 by 4 is 16. 12 is halfway between 9 and 16, so it's going to be more than 3, but it's going to be less than 4. So how about 3.5? That makes sense? So what you do with the half, you put it here. That's 35. Your final answer here is, for approximating, is about 35. So let's see on the calculator. 1, 2, 3, 4, square root of, there, 35 point decimal change. Okay, so that's how this thing works. It works reliably well. Let's do a decimal number here quickly. How about 0.557, a 3-digit decimal number. Now what you do with this, again starting at the decimal dot here, you chunk it up into 2-digit pieces. 7, and there's an invisible 0 after the 7, so there's your next chunk. What you do is, that one's going to be a 0, and that one you're only dealing with the digits closest to this decimal dot. So 7 by 7 is 49, so 7 is close enough. That's it, end of story. Your estimate, square root estimate, is 0.7. Let's see how this works on a calculator. Square root of 0.557, 0.7 plus decimal change, so there is your 0.7. It's pretty close. Okay, last one. Let's see some long decimal number. Okay, that's the last one. 0.000. Oh, what the heck? One more 0 and then 17. All right, let's do this. Again, starting at the decimal dot, you chunk the numbers up into 2-digit portions. Now you start at the units here closest to the decimal 0 or the decimal dot, but that's going to be nothing there. That's going to be nothing there as well. And 17, guess what? 4 by 4 is 16, so we're going to go with a digit 4 there. So the approximated is going to be 0.004. Let's see how this works on a calculator. Last one here. Square root of 0.000017 equals, there's my 0.004. There we have it. Okay, so that's one super fast way to estimate some square roots that don't take a whole lot of time, and you can work with huge numbers. There you have it. You're welcome.